afterwards. So if you missed anything from today, you can rewatch the recording afterwards. And just some other housekeeping bits and pieces before I throw it over to Alex. If you've got any questions while we're chatting today, feel free to drop them in the chat. And I'm sure there'll be some opportunities for questions later in the session as well. But feel free to ask any questions that you might have, because we really want to make sure that you get the most out of this session that you can. So without further ado, we've got quite a lot of people in the room. So I'm going to introduce the lovely Alexandra, who's going to be running the session. Alexandra is a new mentor with Cheat Codes, and is very excited to be sharing some of her wisdom. So over to you, Alex.
Yes, thank you very much, Kate. Thank you for the introduction and the acknowledgement. And welcome everybody to this live session and showcase about Git, GitHub, and the command line. It's also my first live showcase, so yeah, I'm happy to be here with you. I heard you also just joined your first Cheat Codes bootcamp and you're fresh starters. So I'm looking forward to have this session with you. It's very interactive. Feel free to raise your hand if you have questions in between. And there's also time for questions afterwards. Before we start with the actual topic, just a few words about myself. I am from Germany. Maybe you can hear that already. And I've came to Australia first time in 2019. I worked in Melbourne. And now I moved to Brizzy. I work as a data analyst. So, and also as a data analyst, you code a lot in Python and SQL, and I worked in bigger tech companies. So you always collaborate with different tech teams, and therefore you use also a lot the tools, Git, GitHub, and the terminal. Yeah, and I'm work in data analytics since 2019. So if you're curious about anything related to data analytics jobs or skills or any career in that, I'm also happy to have a chat about that. But the topics we discussed today are really general IT tech topics. So yeah, I'm looking forward to talk a bit about the command line, Git and GitHub today. All right, with that, I would start my slide deck if there's nothing else beforehand. Show starting. Let me share my screen. Good. Please give me a thumbs up. Can you see my slides? Yes, beautiful. All right, we actually start with the last word on the slide. So we have Git, GitHub, and the command line, and I would like to start with the command line. So let's start with the command line. Yeah, I like to introduce it with why should we bother learning about this command line? What is the command line? But first of all, why? What problems are we trying to solve with the command line? And I think this GIF summarizes it quite well. We as computer professionals or IT professionals work the whole day or a lot of our working hours on the computer. We will have a lot of little tasks we have to do that involves the mouse cursor quite a few times. And yeah, so let's start and warm up a bit what might be problems when we use our mouse a lot. Maybe you've noticed a few things, and we can also try to think of what might be problems if we work in a tech team or in a company as an employee, and we have a lot of tasks that we do every day that involve a lot of mouse clicks and procedures, and you have to try to collaborate with these tasks with other people. So I collected a few common problems, but maybe that if you have probably also something coming up in your head. So generally, one problem might be it can be very tedious and slow. Maybe you have to really click into a lot of folders and click out, copy that from there to there, and then download something. And then, so it depends, but you have to manually navigate around, and it's compared to what we will see later. It can be a bit slow. Then the next thing, especially in Teams, it's really tedious to document mouse click processes or work that involves a lot of mouse cursor clicks. So if you've seen that, maybe you have to really take a lot of screenshots, and it's not easy to perfectly communicate to someone how we can work by following a procedure with mouse clicks. Also, if you just think about your code editor that you might use for programming later, a documentation where to click which button is just really tedious. So there is an element of, it's difficult to perfectly document what we have to do in our task in general on our computer. Yeah, then also something like debugging errors. Maybe we clicked something wrong in our code editor and all of a sudden everything freezes and we're not sure where that came from. We cannot easily go back in time and maybe rewatch what click did we do, or what happened before that we now end up with this frozen desktop, or whatever issue you might run into on your computer. We will also see later that is also easier in the terminal. And then very importantly, because we want to be efficient, we work a lot on our computer, and that's our main tool we are using. It is generally more difficult to automate tasks with that involve a lot of manual mouse clicks and open programs with the mouse. There are some tools, but we will also see here later in the terminal that's also a lot easier to do. And the last reason that is not mentioned here, but we will also see that the terminal is also just a real programming interface you want to use if you really feel like a hacker. It's a very techy way to communicate and work with your computer. And we will also see that later. All right. So that were problems about mouse clicking. And for me, that is always the main motivation why I really wanted to learn about the terminal, is because of all these tedious working processes with your mouse cursor and opening programs, running programs. And the terminal comes for help. So let's talk about the what. What is the terminal or the command line? When we talk about the terminal, it makes sense to first talk a little bit about the operating system of our computer. So what is the operating system? The operating system is really the most generic set of programs that you have on your computer that control the computer's hardware resources. So it really goes back into how we build computers. And the operating system is the heart of every computer. It's the set of programs that controls how to attribute computer hardware resources. All right. And the operating system usually consists of 3 parts. There is the kernel. So the so-called kernel is, imagine it like the boss, the main boss that makes all the decision. You get a lot of tasks incoming. You want to open your emails, open Excel, and open VS Code. How should we allocate time and memory on your computer to have all these programs running? So imagine there's something like a mastermind, the kernel, that makes these decisions how we allocate time and memory on our computer. And then there's this magic part, the shell. The shell is the command line interface. So that is our topic for the next 10 minutes. That is the part that lets us communicate with our computer. So it is generally called shell. You also call it command line interface, or CLI. You call it the terminal. And it's generally the access point where we as a user can communicate with the kernel. We can give the kernel commands. And lastly, yeah, you can run programs on an operating system. So, and that's really, if you in general imagine you install a new program on your computer, what happens in the background is that you're registering that program with your operating system, and your operating system knows how much time and memory does it need to run this new application you want to use on your computer. So that's really the basics of our computers. And you see the mouse cursor is not involved in these basics. So the terminal or the command line, so this part in the middle, is something really very old that was there back from the early days. The mouse cursor and these visual interfaces was developed later in time to make things visually easier. However, we talked already about a few side effects. So it's very easy with the mouse. You see everything visually where you're navigating on your computer. But the shell or the terminal is the more direct way, and it's just a little window, and you can write commands, direct commands to the kernel, and in that way do the same tasks you could otherwise do with a mouse. So if you use the command line, see it really as, instead of doing clicks and buttons and navigating through folders, you can do the same thing in the command line. Navigate through your computer just via this terminal. And you can also run programs from this. You can start certain programs from this terminal. And we will see later that it has all these advantages. It gets over time a lot quicker to use the terminal. You can, because you have hard-coded commands, you can very easily go back in time and you see what command you executed when you have an error. It's very easy to automate certain processes because they are simply really more like a programming language or like a procedure. And it's easy to take a script and automate some certain steps that you want to execute in the command line. All right. If someone has a question, just feel free to raise your hand. Just in terms of terminology, there are a few different command line interfaces out there. It depends what operating system you have, and just that you've heard a few of them. You don't have to now read it all in detail, but every different shell that was developed over time has a few pros and cons, so it's optimized for a certain thing. So there is the general command prompt on Windows, there's PowerShell, there's Bash, also a very common shell on Mac and Linux. There's ZSH, that is has a few more visual features of the Bash command line, and there is Git Bash for Windows that is already optimized to work with Git in the terminal. Okay, so I mentioned already we need to learn a few. So if we don't use our mouse in the beginning, it takes a bit more time in the command line interface to get comfortable with all these commands, how we can exactly talk to our computer via this interface. So I want to introduce you to a few of the most common commands and show you that in my terminal. For that, let me just quickly split my screen.
40 ounces, 1.2 liters.
Sorry, I'm not sure. Was that a question?
No, sorry.
Okay. Good, all good. All right, I'm back. You should see now my screen split. Is that right? Yeah, perfect. Okay, thank you for the feedback. So it might be, I would say for tonight, lean back and watch the show, but every computer, like you're on your computer now, so you all can access your terminal. Maybe you have also done that before already. There is a different way how you can open a command line interface on your laptop. I have opened mine on the right side. Also on the right side, you see my terminal, and on the left side, you see the slides. I hope you can still read the commands. We can make this a bit larger. All right, so let's have a look. How can we now navigate in our computer just with this black window without our mouse? What you have to keep in mind when you start working on the terminal is the folder structure in the background, because you don't see it visually. Yeah, I want to show you that that is something that you have to get used to in the beginning. So let's see, because if I ask the terminal, where am I at the moment, that would be the command print my working directory, I get a folder path or a file path. I am in users Alexandra Mai. All right, and now if you imagine you on your computer would like to go into the documents folder, so you see the little tree picture on the slide. We are in a certain user and then want to go into the document folder. Or first of all, maybe we want to see all the folders that are available from my main user path. If you look at the last command, maybe that's actually what we do first. We want to list all files and folders we can click from that directory we are in at the moment. So if I type ls, it gives me as an answer everything I can access from where I am at the moment in my computer. I mean, you have the same problem with your mouse. If you are in downloads, you can only open and click into the files that you have in downloads. The same as in the terminal, you can only open and click wherever, depending on where you are in your terminal. Okay, so at the moment I'm on my main layer of my user files. Let's move into documents. So how can I, with the mouse, I would just click on documents. In the terminal, you have to give a command. The command for that is cd, change directory. So if I type cd, that is the programming language we have to learn and get used to when we want to work with the terminal. I can open the documents folder. And you see it changed that you now see document next to this green arrow. So it gives you even an orientation in which folder you are at the moment. If I now again press ls, I see different files. So I see all the files that I have in my documents folder. All right, so we just navigated into a folder. How can we navigate out of this folder again? We have to type again cd, and you see it on the left side. Change back to the parent directory would be with ... So I'm back in my main file system of my user, and I again see all the folders I have available. All right, and we will see more with the terminal later when we talk about Git. So it should be a short showcase here. I know there would be a lot more I can you could do now. Let's go back into documents and create a folder in here. So that's also a very common command. You see it on the left side, mkdir, create a new directory. Just checking. Yeah. So let's say we want to, in the documents folder, create a folder called my folder, mkdir, my _ folder. Okay, cool. If I now run ls, we see a new folder, and you see here in the middle, we have my folder, and I could navigate into my folder. So I think it's a good practice in the beginning, just get used to just navigating around in your computer in the terminal. And that always works with cd, ... Ask your computer where you are at the moment. With pw, you can create new folders with mkdir, and there are a lot more commands. You can copy files with cp, and you can also run really programs from your terminal. And the program that I show you later is how we can work with Git from the terminal. But for now, I would leave the showcase here because we have our time constraints for this talk. So let me go back, and we will revisit the terminal when we are in talk about Git a bit more. Okay, let me share my main screen. All right, so yeah, so far we learned about the terminal and that it will be a very powerful way how to navigate and work with our computer. One program that we can very efficiently use in the terminal is GitHub and the program Git in our terminal. So I will show you that later. Before we do that, let's talk about our second topic, GitHub and Git. It's another general concept that is very essential for any type of tech work that you do. I usually like as a warm-up version control in general as a topic. If you think about maybe you had Teams or a job before where you had a shared Google Sheets file where a lot of people would put numbers in and formulas, and these numbers and formulas report every week a certain business number, and all of a sudden you see one user changes this Google Sheets file in the middle and a formula doesn't work anymore, and it's possible but a bit tricky to find out who did what change in that file, what caused an error. And if you imagine in programming, these things are really, really important. If you collaborate on a big coding project together, the most important surrounding system or structure that you need is a good working control system that shows which of the employers did what change on this app, when did what change happen in this app. Maybe there was a bug so that it's easy to find out how to fix that bug and go back in time. So GitHub and Git, the main purpose is a professional version control system for programmers. But GitHub is in general also a lot more. So first of all, let's warm up a bit what is GitHub in general. I will show you my GitHub profile in a second, but I guess you've all already signed up for GitHub. So first of all, it's a tool that you sign up for. You create your own profile. You can upload your profile picture, and you can really see it as your business card in tech. So if you apply for jobs later, you can share your GitHub profile. It's kind of the Instagram for coders. You can show your projects you worked on. You can follow people. It's a network. You can collaborate. You can search for different coding projects and find content that you like. Really like an Instagram for coders. It is also a cloud storage for programs, because everything in the end, every program that you store in GitHub is saved in the cloud. So it's also a very important backup tool. Your program doesn't get lost. If you lose your laptop, your program is always saved in this cloud storage for GitHub. And the most important point, it has this Git version control that we will talk about. And I said that the Git version control system is important to collaborate effectively in large teams on large programming projects. And I also mentioned it's really great. It's also just a very big open source community. The code is public, like some code is publicly available. You can share the code, you can look at the code, download the code, try the code out yourself. There's usually a manual behind. So it's a great way to meet other people that work on similar projects. You can contact them. So also just a good way for a good open source community. And it's also a way for you to show your projects that you worked on. So if you apply for a job later, or you have certain projects that you worked on, it's always a good idea to publish them on GitHub. So yeah, you can also contribute to this open source community and show your projects to the world of coders out there. All right. Let's have a quick look into GitHub itself. So let's go to the starting point. You should see my GitHub. Sorry, let me just go to my main user page. Here we are. So this is the Instagram for Coders. I guess you've all already seen that. You have your profile section where you can look at your current own coding projects that you published on GitHub. You have different visibility. They can be public or private. Oops, sorry. Yeah, so you see here a little public or a private sign. You can edit your profile, you can follow people, you can star other projects that you really like out there. So usually I would maybe know a certain person and follow that person and start clicking into their coding projects. You have your main dashboard where you also see your recent working activity. You see in which projects were you recently active. And if you're part of a company, that's a very important part, your profile gets added to an organization, and also companies internally host their projects that they're working on GitHub. That means that it's, of course, completely private and not visible for the public. But you as a member of this organization, you can access all the code from this company via your general GitHub profile. So it's very likely that you later in your job, because GitHub is the biggest tool for that, that you later in your job have all your programs published on GitHub, and that this organization is using GitHub with the main version control system and also as a cloud storage for all the software they develop. So I could here, for example, switch between my private GitHub and the one of I'm, for example, part of the Neue Fische organization, and I could switch to that profile, and then I could browse my company's code at the same time. But at the moment, I'm in my private GitHub part, and I would like to show you that we create one GitHub repository together. A GitHub repository is one sort of a folder in GitHub where we store the code for one coding project. So that would be the main base that you're working on. You're always working in different projects. For example, I have a GitHub repository that is called Pandas AI, and that has one coding project in here. So you usually have a README file that describes the project, and then different coding files that all belong to this one project. And these projects or these folders for projects are called repositories. So yeah, I would say that's already a very typical nerdy word. And if you want to shortcut it, you can even just call it repo. So let's create our first own GitHub repo. Maybe you've also done that in the bootcamp already, but I just show you it's really just a few clicks. You can choose your owner. So I want to own this repository. You can give it a name. We can just call it test repository for now. You could add an optional description. You can decide if it's public or private. Add a README file where you give general introduction. Then very important, you have maybe sensitive data on your computer, like a password that you need for this project, but you don't want to publish that anywhere publicly. So there is a certain so-called gitignore file that holds all this information about private information that you don't want to share publicly on GitHub. If you know you work in a certain programming language, you could add that here. You can choose a license. That just means how can the public access your code. So do you allow others to use and copy your code or use your code for commercial use cases? Then you can choose, for example, the MIT license. If you want to be more stricter with your licensing, there are lots of other licenses you can pick from. But that's everything you need in the beginning. And then we click on Create Repository. And that is what you see. So if we look on top in the navigation, I find you need to get a bit used to that in the beginning. So you see my username, and then I'm in this folder test repository at the moment. So I would really see it as a folder in GitHub, and that folder is only about the certain project we work on that is called test repository. And at the moment, this is empty, and we have also not many files in here. But that could be later your app that you're working on in a company, for example. Okay, we created a GitHub repository. Let me go back to my slides. Because I mean, it's great that we have our coding project that we want to work on online on GitHub. Okay, so that's done. But I'm sure you know, and you were already wondering, usually as coders or programmers, we want to work locally, or we really need our computer to write code because we want to make use of code editors. We want to use something like Visual Studio Code or other tools to work in. So how do we come from this browser code project to our local machine and that we can work on the same project on our computer? That's the main question, and that's where this big version control setup now also comes in. Because imagine the general project is saved in the cloud on GitHub. All your team members can access the code for the project. Let's say you develop an app to connect drivers and people that need a taxi ride. So this whole code is stored on GitHub. All the collaborators in the company can access this GitHub repository online. But at the same time, all of these employees have certain tasks they work on. They develop a certain feature, and they need to write code locally on their computer to be able to use a code editor. They cannot do that in a browser link. And if you just take a bit of time and imagine that complexity, that 10 different people at the same time work on different features for an app, all on their local computers. At the same time, you host the main app on GitHub, which is a public, like in your browser in the cloud. So there needs to be a synchronization process between your local computer and what you're working on and this cloud storage. And at the same time, it's very important that you have a very strong version control, that all these different people that write different code, that doesn't create conflicts with the main app. So it can be very sensitive code, and you always want to make sure that the code is tested before it's accessible for everybody to use. Yeah, so there are a few more things to Git that we now want to talk about. And I would say we start with just this updating process. How can you work locally on a public GitHub repository? All right. That's the situation. If you look at that slide, on the left side, we have the remote. You could also call that remote repository on GitHub. On the right side, we have our laptop where we want to work locally in our repository. How can we connect? How can we do that? There is a lot of language that you use in this Git world. You heard already now the Git repository for this folder, and the step of somehow creating a digital copy on your local computer, that step that I show you now is called cloning. So it's, yeah, you imagine you want to have just a perfect copy of that point in time of the version of that app on your computer to be able to work on it locally in a code editor. And yeah, okay, I show you, I think that is the slide. I again show you that in a split screen. Okay, give me. Left side and right side. Just need to. Okay, a lot of things going on. Let's, yeah, what is everything that we see on my split screen? So on the left side, you see my browser where we have my GitHub repository. On the right side, you see at the bottom a terminal I've opened. Because I told you, Git is a great program we can very efficiently use with the terminal. And on the top, like overall, the program on the right side that you see here is Visual Studio Code. So one code editor that you can use. So our goal is, remember, to bring this coding project into my local laptop so that I can open it in Visual Studio. And how we want to do that is with the help of the terminal. And remember the slide, so the step is called cloning. The command is git clone. And I just show you how that works. So maybe just a side note, when you the first time work on your terminal, you have to install Git as a program on your terminal so that your terminal can communicate with your GitHub profile that you registered on. So my terminal knows that I'm a user called My Analytics Journey. So my terminal here on the right side knows who I am. As soon as I now type any command after Git, it runs the Git program on my computer. So it understands that I'm My Analytics Journey user and I can communicate with this public GitHub profile on my terminal. Just if you do that the first time, you have to install Git in your terminal. You have to authenticate your user, that build a safe connection between the terminal and your GitHub profile. But I've done that already. So I can communicate via the terminal with GitHub. The step to create a digital copy for this repository is called cloning, and we need a digital address what do we want to digitally copy or clone, and we have several ways to do that. You just have to have a digital URL so that your terminal knows which repository you want to clone. I always choose the SSH connection. So you copy that connection, and then before we git clone it, because it's really, that will be our folder on our laptop where we store all the files, all the code regarding our drivers app. We want to make sure in which folder on our computer do we want to copy that. And you could, for example, create a new folder that is called my app, or maybe not, rather for now you would maybe have one folder on your computer that just holds all your GitHub repositories. So it would be really quick. You can create a new folder, mkdir, my repositories, enter. And then we move into that folder, just that you have your work a bit organized on your laptop and it doesn't get a whole mess at the end. Now we are in my repositories, and in here, I want to copy this Git repository. And to create this digital copy with Git, the program I use in my terminal is Git, and the Git command I have to use is clone. So again, I'm talking to my computer. I give my computer instructions with certain commands. So you have to just follow the recipe, whatever is exactly the command. In that case, the exact command we need is git clone, and then you paste this SSH link. You hit enter, and then it's cloning this repository onto your machine. So that's really great. If I now do ls, I see, cool, I have this folder, test repository, in my terminal or on my computer. And I mean, now I brought it to my computer. So to actually start writing programs in it, I would like to open it in VS Code. So you can click open and just simply open, for example, my repositories. Yes, I trust the author. And then you see the same folders or files that you have publicly on this project on your computer. Okay. That is great. Let's actually quickly again back to the slides. There are a few more. How can we now actually work with this program? Oops, sorry. Maybe I just show it to you for now I just show you the problem for now in this split screen. Okay, so it's great we have our code in here. Let's say, because I love programming in Python, let's create a new Jupyter notebook in here. My first code.ipynb, that's the file ending for a Jupyter notebook. And we can easily run Python in here. I'm sure you will also learn Python at some point. So we can now write code in here, and imagine you work on your big app. So you have all the code available and you can locally access code. Okay, that's great. I just wanted to show you there's a problem. So now that's your personal code on your computer. If your colleagues want to see that code, you have a synchronization issue. So the my first code file is not visible publicly on GitHub. So one big step we have to learn when we want to start working in a GitHub repository and synchronize our work is how can we now update local changes so that they are publicly visible on GitHub. Okay, for that, we can again use the terminal. Just give me 1 second. Apologies. Okay, that works great. And then I need Okay, beautiful. I'm set up. Let me share my screen again. Good. So this, you see now the slide deck on the left side. So that is the problem that I just showed you. We now start working locally. That is the right side of the slide, the white background, but it is not synchronized on GitHub. Okay, and maybe you've already, so Git is really tedious in the beginning, but I would motivate all these steps that you have to follow, that it's all about the safety of your code later, that you don't break accidentally an application, that people can easily see who did which changes, that people have the opportunity to first review your code before it's published. So actually, Git is doing, it takes a lot of responsibility from you, because it gives your company or your team a system that everybody can double check code before. It's very easy to revert changes again that you made locally. But the downside is that in the beginning, to publish changes, you have to follow a very strict procedure to tell Git that you worked on something that you would like to publish. So this is the example that we look at now. We added a new file and we wrote print hello. So we have some local changes. All right. First of all, the overall command you can use all the time is git status. That gives you, sorry, typo. Sorry. This message means I'm still in my main folder. Now, to be able to work on my and update my changes, I have to actually go into this repository of this folder. So now I'm in the Git repository. I can check the status of my files. And this is now the magic, because this is a Git repository. Your computer tracks all the changes that you do. So your computer noticed now, your terminal tells you that, untracked file, there is a new file that we did not add so far or published to the remote repository. So with Git status, you always see the current status of your local working environment. What files did you update? Where did you make changes? What changes did you make? So you get a good overview. You also see here a little U for untracked. So you also get little icons that help you to see the status of different files in your Git repository. All right, so this is our situation. First step is there is a so-called index. So every change that we later want to publish, we can, for now, I would see the index as like a local, like a temporary storage for all the changes that you want to push to the public repository. Because it's again about safety. Maybe you don't want to, so there's one feature that you worked on that is already done, but another feature you're still actively working on. So you only want to push or update part of your code and not all your code. So with git add, you can specifically name files that are ready to be published. And you can, so let's say if I'm ready with my first code file, I can git add this file to my local index so that it later gets published. But you're basically just starting to collect files that you would like to publish later. Git add my first code. And then if I now, you see it changed from an U to an A, so we added that file. And if I now run git status, you see, there is a new file that I added to this index that keeps track of whatever I want to push or not push. Okay. And maybe for now, that's it. It could be that you have maybe a different file you want to add and there's another file you want to leave out. But for now, to keep it simple, we just want to, this file is ready to go, and that's also the only file we want to publish. Okay, so on the left side on the slide, you see the first thing you have to do is git add. And the next step is So the git add, as I said, adds it to this temporary layer. It's still easier to revert changes if they're just in this local index. If you're now really sure and tested your code and you're ready that this really should get published, you have to make another commitment. I would really think about it as a commitment. So it's just the next safety layer. So you have 2 layers to be really sure if you want to add and publish this file or not. If you want to add it to the next final push to this public repository, you have to again run a command and commit this change. So git commit is really the final change that you, so you really commit to this will get pushed now, and I'm sure that I want to add these files. So the git add is more temporary, that you don't lose changes in case your computer, I don't know, breaks down. You saved it locally, but you have not yet committed it. So, you know, you're maybe still in like an in-between layer where you want to keep track of everything, but don't, maybe you're not ready to, if you're really sure if you want to commit it. A day later, you are sure you want to commit all of that stuff. So you type git commit. And a good practice is to provide a commit message. So we want to say add new file for printing hello, describe a bit what you're doing. And then that's it. So git registered now. You told your computer there are things you want to publish to the remote repository. And maybe you see already that the terminal, it all works quite quickly. If you imagine you do that every day, 5 times, you get really fast in the command line. All right. And then the last command is you can commit multiple things. The last command to really publish everything that you committed so far is, so it's really like the last safety layer. And think about it as this is your friend. These safety layers are your friend, because later in a company, you don't want to accidentally publish something that maybe breaks a different part of the app. So these why you need these lots of steps, I would really see them as your friend. They give you extra safety layers. Exactly these steps make it later easy to revert changes, to fix a bug really quickly, and it makes it easy to look into older versions of your code. So you have to get used to that a bit in the beginning, but in the end, that all is just there to help you, that you have a very solid version control. So the last thing, if we are really, really sure and we have finalized everything, we can push this change. And I can now just click push. That's actually a big thing to click, because now it will really update the public repository. If you're in a company setup, you can add a lot of safety features. For example, between the commit and the push step, you can enforce that someone else has to review your code before you can push it. You can enforce that certain testing procedures or testing scripts need to be successfully run before you can push something. In my case, it was a very easy push. I just did git push, and now it's publicly available on this, in part of the public project. But companies add a lot of even more safety layers usually between these different steps. Okay, and then the change is published. So I think you get the idea. Let's have a look in my remote repository. So if that's still my old browser. We don't see it yet. That's just because I haven't refreshed. And now if I refresh, great, we can see my first code. It's published. All my colleagues can see my code. They can start using my feature that I worked on. they can exactly see what I changed. They see Alexandra Mai added that. They see at what time that happened, and they see what I changed. You get a whole history of all the commits someone made in the commit history. So you see I did a commercial commit and then add new file. You can really easily go back in time and see what was it that Alex changed now a few minutes ago. What code lines did she remove? Which code lines did she add? You can chat to your colleague and make a comment if you're sure this was a good idea to add this code line or not. It's all publicly visible, and that's just a really great feature for collaborating in a really big software project with a lot of different people. And that's really just also the first little step that we've done is just updating local work to our public GitHub repository. Now, maybe that makes you curious that there's just, of course, a lot more different Git functionalities that you can use. Like, how can you now merge different versions that different people worked on their computers? That's all beyond this little showcase for today. But for me, it's always important to just bring you across the main idea that all these little tedious steps to update whatever you worked on locally, to publish that, they are a big safety net for you to help you to revert changes easy, to see what you programmed in the past. It's very easy to see publicly who worked on what, so that you maybe get already a first feeling of how this is really an advanced version control tool and a lot more than just, in OneDrive where you see, where it's a bit limited what you see. And keep in mind also all these additional safety features that companies usually add, that you have to run successful tests before you can publish something, or that you have to have someone that reviews your code before you can publish code. All right, that is basically it. I just have one more slide that just says, amazing, we did it. If we recap what we did in Git, first of all, we used the terminal to be really quick in talking and running Git commands. Then we created a repository online, that is our project folder. We cloned that repository so we can locally work on it. We made local changes on our laptop, and then with the help again of the terminal, updated and pushed, added, committed and pushed these changes so that everybody now publicly can see these changes on GitHub. So it's a whole journey, and it's always between synchronizing GitHub and Git. And the program that makes it really fast is the terminal that we can use on our local computer. So I think these topics go really well all in all together. That would be it from my side. I hope the little showcase helped you to understand general ideas or motivations about the command line Git or GitHub, and that you enjoyed it. I'm here for questions if you have general questions, if you're curious about more different examples. Happy to have a chat. And if not, thank you for your attention. Thank you for listening. Nice that so many people showed up. I wish you all the best in your journey at She Codes. I'm sure you will use the command line a lot. You will use Git and GitHub a lot. And I know you sometimes hate them, and sometimes they are great and powerful, and you are amazed of these tools. Yeah, don't give up. The terminal and Git are two things that are very strict. If you don't have the exact right syntax, they complain, they throw you an error, and it's like, oh, what is going on? But they see them as your friend in the end, because they are so strict with it. They help you. It's very easy to track back what exactly did you do wrong. You can follow in the terminal. You see the history of your commands, what you executed. That would be a lot harder if you just have mouse clicks. And the same with Git. I mentioned already how all these little steps in the end help you to have a safe code and safe collaboration with your colleagues. But I just wanted to also say, because if you're new to these tools, I feel your pain. It's not easy to learn them in the beginning and to find out all the little syntax issues. But stay in there, they are rewarding after a while, and it's all just routine. If you do it over and over again, it will get easier.
Thank you very much. I just wanted to see if you're already seeing the chat down there. We got like 2 questions there. Can you please check?
From the beginning, maybe we could just a side note. How
Yeah,
can I?
this one that do you ever git commit and skip git add just because you're sure you want to commit, or is it not a good practice to do this?
Here. Did you ever git commit? In the default setting for Git, it doesn't allow you that. So that's why I mean it's a safety step. You have to always first add, so git add everything, and then you commit automatically everything you added. So it's not possible to just directly commit. That's why I said Git is very tedious. It's very strict with you. Yeah, so that's not possible. You can try it out. You will get an error message.
Thank you.
Is there a different question I missed?
Yeah, I think that's another question.
Which one is that? Yeah, here. Does it matter if you use... yeah. No, it doesn't matter. So the question was if it matters if you use HTTPS or SSH. No, it doesn't matter. I personally like... no, you don't see it. Sorry. If you remember, you could choose different options. SSH is that the advantage is you don't have to always type in your password again. If you log into GitHub, remember you also just have a password and a username. You can one time put an SSH key to your profile via this SSH key, so it's a safe connection without password authentication. That's one advantage why I like to use SSH. So they're just how you can establish the connection between your local computer and GitHub, but they all work in the end. But I recommend trying out the SSH connection if you have troubles that your current setup maybe requires always a password. Then you can try out the SSH connection. But there's also an article I see someone note. So there are probably also a few other things, advantages. So yeah, feel free to read this article. I also had, I'm sure you have lots of content from, no. No, I think that takes too long. Sorry. If I find it in Slack, I can send you a few more links for some, there are a lot of games you can play. I'm sure you have plenty of material, but I can also send you my collection that I have. All right. Someone wrote in German. Vielen Dank, Alex. Nice. Yes, gerne geschehen.
Dankeschön.
Here. Yeah. All right. Are there any other questions or something you want to share?
If you probably don't mind, I might reach out to you afterwards because I do have lots of questions, but I'm sure they will be boring for other people.
Yeah. I make sure that I connect with you all. So I'm also in the Slack organization of SheCode. So I'm not sure if you have probably all one Slack channel if you're all in the new bootcamp. I make sure I ask Kate how I can join that Slack channel, and so happy to do that.
Excellent, thank you.
All right, you're welcome. Good, then if there's anything else, I'm here for a bit longer. I mean, we have a bit more time. Yeah, and as always, feel free to please send feedback to Kate. As always, I just write it in the chat. Feel free to send feedback to Ollie or to Kate if you have other ideas, what you would have liked to learn or what you liked about it. Yeah, that always helps us. It's a bit hard. I was also struggling 45 minutes. What do you put into the 45 minutes, right? There's a lot of things to talk about, so you have to make cuts somewhere. Maybe there's a different topic you would have liked to see. That's always, yeah, good to hear for us. Yeah, someone asked if I have still time. Yeah, if I can share about my journey as a tech lady. Yeah, big topic with women in tech, or where should I start? So I studied maths and computer science, which was already, you get thrown into studies that have generally a bit more men. Needed some time to get used to this. Okay, I will probably collaborate with a lot of male colleagues and not have, a table with just women around me. So I think I had my whole studies to get used to like teams where we have maybe generally a few more men and the women are a bit in minority. So I think that is probably in the beginning was a bit intimidating, but I got used to it, or it's fine over my studies, probably. I got used to that environment. And then, to be honest, it was also the same in my first jobs I had. It's, yeah, I think crazy when you think about it, but it's just almost like a standard that there are more men than women in tech jobs. So then also my tech teams I worked in were more men, which is fine. I generally, that was okay for me. The important thing for me was to find other women I can look up to, that I can talk to, that I can have a private conversation with, that maybe give me tips about, or where I can just communicate it maybe in a bit a different way than I would talk to my male team lead. If also maybe our connection or our personal vibe is not exactly matching, but we are working together professionally, that's great. But I always try to look for other for women I can exchange with, that I have, that I'm really vibing with them, and just get tips about things I felt insecure about. I think that was important for me in the beginning, to feel confident about my behavior, how to work professionally in tech teams, how to communicate, how to show confident, how to show what are your skills, and not to be overconfident, but also, it's tricky, I think, to have this whole, how do you show yourself in this environment? And then there are lots of other confident people around you. Maybe most of them are male, and they have no problems to show off how amazing they are in coding, and you sit there and think, I am actually also good at this, but I have maybe more struggled sometimes to show that to people. So I had to find ways and talk to people. What are situations where I feel insecure? Why do I feel insecure? Or what is my, hindering me in really showing my work or my projects? And then push myself a bit to really show my work, show my projects in team meetings. And by that, I think I just got more and more confident And I think that this topic of confidence was probably the most important thing I had to reflect on in my, journey as a woman in tech. I think it's that for me, it was that I don't get too intimidated by other people talking too confidently, and then I talk myself a bit down or something like that. So I would say my main tip was how can you find confidence in your skills? What are you good at? What are your unique skills that you can add to that team? And how can you show your skills? Is there maybe a weekly meeting where you can share projects? And give yourself a little push to try to show what you're good at, but also reflect on what are things that make you insecure, and how should an environment be that you feel more comfortable or more confident. So I think in the end you need to feel comfortable in your team and feel good about yourself and confident about the job that you're working on, that it's a good job and that you're actually achieving something. And I think that worked quite well. So I just got more confident, and then it also works better with the career, I think, in the end. I think that's my main tip, or what I had to learn in the beginning. So I would say I was definitely more shy in the beginning and did a lot of how can I talk confidently about tech topics. No worries, you're welcome. All right. Then thank you very much. I mean, it's 8:30, I guess. It's at least 8:30 in Brisbane. It's not 8:30 for you. For you, it's 6:30. Okay, you have maybe dinner time. I have evening time now. So I wish you a nice evening. Nice to meet you, and have a great and amazing time at SheCodes. Bye bye.
Thank you.